Hi folks, here is the last section of chapter 4. There's only 5 sections in this chapter. And this section is going to provide us another way to compute integrals, more complicated integrals than we've been able to do before. Today we're just going to talk about indefinite integrals, that is, how do you find antiderivatives. So before we can talk about antiderivatives, we need to go back and remember something about derivatives. So if you want to take the derivative of a composition of functions, f of g of x, you use the chain rule and you get f prime of g of x times g prime of x. That is the derivative of the outside with the inside in there times the derivative of the inside. That's the chain rule. But what does that tell us? That tells us that f of g of x is the antiderivative of all this stuff, f prime of g of x times g prime of x. That means if I want the indefinite integral of f prime of g of x times g prime of x, indefinite integrals are just antiderivatives, so the indefinite integral equals f of g of x plus any constant. I can rewrite this, instead of little f prime and then little f, I'm going to write this as just little f and capital F, so capital F is the antiderivative of little f. And this tells us how to take the indefinite integral of something that looks like a function of some stuff times the derivative of the stuff, right? F prime of g of x times the derivative of g of x. Well, there's an easier way to write that and an easier way to remember how to do that. So this is called substitution, often u substitution, because we use a new variable which is traditionally u, but in occasional situations we might use a different variable, v or w or anything else really. And we're going to let u equal the thing inside the other function, so the inside part of what we want to integrate. So u is g of x from the previous slide. And then we take a derivative and we get du dx is g prime of x, and that means I could multiply both sides by dx, sort of, and write du equals g prime of x dx. So the part of the integral that we had before, g prime of x dx, we will be able to replace with du. So this is what we had on the other page. The integral of f of g of x times g prime of x dx is capital F of g of x plus a constant. Now replace g of x with u and g prime of x dx with du, and this looks much nicer. The antiderivative of little f of u du is capital F of u, which just tells us the indefinite integral is the antiderivative, which we knew all along. Right? So g of x, remember, is u, g prime of x dx is du, and so we get this way of rewriting a complicated looking integral to make it look like a simple integral. The integral of f of something times the derivative of the something we can rewrite as just f of u du if we make the substitution u equals g of x. That's called the substitution rule. So for example, let's say I want to find the indefinite integral of 2x times the cube root of x squared minus 4 dx. That is, I want the general antiderivative of that function. Well, I've got a cube root of something complicated, cube root of something that's not just x. So I think of that something there, the x squared minus 4, as my inside part, my g of x. So that's what I want u to equal. U equals x squared minus 4. I take a derivative and I get du is the derivative of that thing times dx. So du is 2x dx. And now I'm going to rewrite the integral. Notice that I have 2x dx. They're just sort of separated physically, but I have 2x times dx in my integral. So that stuff gets replaced with du, and the rest of it is the cube root of u. So my integral turns into the cube root of u times du. And that's easy. The integral of a cube root, which is really just the integral of u to the 1/3, I add 1 to the power and then divide by the new power, u to the 4/3 over 4/3 plus a constant. Make it look a little nicer. That's 3/4 u to the 4/3 plus a constant. And then because my original problem had x's in it, I don't want my answer to have this other variable in it. I want my answer to go back to being about x's. So I'll substitute in u equals x squared minus 4. So I have 3/4 times x squared minus 4 to the 4/3 plus a constant. And there is the answer. There is the indefinite integral, the antiderivative of what I started with. Remember, you can always check antiderivatives, check indefinite integrals, by taking the derivative of your answer. So, is the derivative of my answer equal to this thing I want, 2x times the cube root of x squared minus 4? Well, the derivative of my answer, it's something to the 4/3, so I bring down the 4/3 and then reduce the power by 1, so that makes the power 1/3. And then the chain rule says I have to multiply by the derivative of what's inside, so I have to multiply by 2x. Rearranging that, and I just get exactly what I was hoping to get. So my antiderivative is correct. Right, so that's the substitution rule. We'll do lots of examples in class. Here's the video question to bring to class. If you want to use the substitution rule to evaluate this indefinite integral, what substitution should you make? That is, what should u equal? I'll see you in class.